Jai Hind. In continuation with our educational videos of PERIO Subharti, today's video will be demonstrating the various types of implant kits along with the armamentarium, that is Physiodispenser. So the objective of this video basically would be to explain in detail the advantages, disadvantages of various kits as well as the rationale of using a specialized armamentarium for implant dentistry. In the subsequent video, the next one, we'll be showing you the actual procedure of hands-on of placement of implant in an artificial mandible. So let us start with the demonstration of the kits. So starting with the implant kit. So basically, this is the Alpha Bio implant kit, an Israeli system. This is the old Alpha Bio, this is the new Alpha Bio. We have the Indian kit, iFix, designed by IIT Delhi, and we have the South Korean Ostem. Now, the reason why we are covering up all the kits is to emphasize on one basic point, that basically more or less the kits are the same. Slightly the design of the components vary according to the system that we are using, but on the whole there are just 5 main components in each and every kit. First are sequential drills. This will be covering up first. Each and every drill is roughly 3,500 to 4,000 rupees. So this is the main part of the kit, sequential drills. I'll cover up the importance of this thing, the function of this thing. The second important component, the most important component, is the torque ratchet. This is the second component. The third component is depth gauge. The fourth component is extended mount. And the fifth component is hex driver. So once we have an overview of these 5 components, basically any kit we'll be able to understand. It is same. So we have drills, torque ratchet, depth gauge, extended mount, and we have hex driver, right? So now let us understand. Suppose I have chosen that according to the site available, according to available bone in a patient, I'll be placing this size implant. So based on available bone, based on which tooth you are replacing, an anterior or posterior tooth, we try to place the widest and the longest possible implant. From a BIC point of view, bone implant contact would be good, chances of survival of the implant would be good. So let's say for example, this is 4.2 by 10 millimeter implant. We are presuming that the diameter is 4.2 and the length is 10 mm. So what should be the osteotomy size that we are planning to drill in the patient's mouth for placing an implant of 4.2 by 10? So the rules of osteotomy preparation remain more or less the same. First and foremost, the rule is simple. This bone is living tissue. Respect the living tissue bone and the bone will respect your implant. So it has to be atraumatic drilling. This atraumatic word I'll be elaborating during the course of the demonstration. Okay. The thing is, with regard to the dimensions of the osteotomy, we have to understand first. You have to understand what should be the final width and the length of the osteotomy. So for an implant of 4.2 by 10 millimeter, the final osteotomy width should be slightly smaller than the diameter of the implant. So what's the reason for that? The reason for that is bone is living tissue. The moment you do osteotomy preparation, that is bone drilling, some amount of bone resorption is bound to occur. So in order to compensate for that bone resorption, we say osteotomy should be narrower than the diameter, so that ultimately even if slight resorption occurs, your implant does not become loose. That is the first thing. This is with regard to the diameter. What about the length? Again, same resorption you are expecting to occur at the crest also. So as a rule, the implant should be placed either equicrestal, preferably subcrestal, never ever supracrestal. So what does that mean? The depth of the osteotomy should be slightly more than the length of the implant to be placed. So suppose I have decided I will be placing, let's say, 4.2 by 10 millimeter implant. My last osteotomy drill would be roughly 0.5 mm lesser then the diameter of the implant, that is 3.65 millimeter, and finally the depth should be, for a 10 millimeter implant, roughly 11 millimeter. This much part is clear. So we have a rough idea that the dimensions of the osteotomy should be narrower and longer than the size of the implant to be placed. That is the first thing. Now, before starting with the second aspect of atraumatic drilling, please understand that there are various types of drills according to the system that you are using. The basic principles of osteotomy preparation remain the same, irrespective of which system you are using. But there are slight variations. For example, the drills which I have in my hand, these are basically of the old Alpha Bio system. So this has basically markings 6, 8, 10, 11.5, 13 and 16. You are supposed to memorize the markings at the time of drilling. You are supposed to remember how many marks have gone inside and how many are remaining. Now, if you were to compare it with the newer Alpha Bio system, this basically has color coding. So, color coding makes it easier for you to remember those markings. So, now we have a color coding with till 8 millimeter. So, instead of remembering 6, 8, now you know till the first band I am 8 millimeter, at 8 millimeter. Then we have a clear portion between 8 to 10 millimeter. And then again 10, 11.5, 13, 11 to 13 we have a color coded region. So broadly, if you were to say, you can remember, first color coding extends till 8. If this black band is inside, you are beyond 8. Second color coding extends till 13. So we have 10, 11.5, 13. If the second color coding you have gone inside, that means basically you are beyond 13. Now, many of us might be finding this thing confusing, right? So it is a personal choice whether to choose a drill without color coding or to choose a drill with color coding, right? So this is one thing. Now, many of us might be finding this thing itself confusing, trying to remember the marks 6, 8, 10, 11.5, 13, 16 and trying to remember it each and every time we are doing an osteotomy in the patient's mouth. So this is where a few Israeli systems, this was an Israeli system, few other systems, the Indian system came up with an innovative thing. This is available in other systems also. So this is the iFix kit designed by IIT Delhi, a made in India system. So what they did was that in addition to the same color coding etc. on the drill, they provided something known as drill stoppers. So these are drill stoppers. So can you see 10 millimeter is written. So if I have to place a 10 millimeter implant, I'll be taking this drill stopper and I'll be attaching it on this drill. So now I don't have to worry about counting. Straight away in my osteotomy, it will stop at 10 millimeter. This tip is not included in this 10 millimeter. So what that means is that we might be worried that if we do it till 10 mm, our implant might be supracrestal. No, it will be subcrestal only because 0.5 to 1 mm of the tip is not taken into consideration. So straight away, this drill stopper can be used. Then once you are moving on to the next drill, the same stopper can be applied to the next drill and you can continue with your osteotomy like this, right? So makes things easier as compared to the first system where drill stoppers were not there. So in this case, if I had to put it inside, I had to remember 6, 8, 10, 11.5, 13. Now no need to remember. With that system directly you can use a drill stopper. So this is drill stopper system which is available in Alpha Bio also, but it doesn't come in the routine kit as such. Here in iFix it comes in the routine kit. So this much part is clear. Now the last kit that I'll be covering up is Ostem, a South Korean system. So what they did was, no need to put drill stoppers also. They put different lengths of drills according to different implant lengths that you are supposed to put. Meaning, if I have to place a 7 millimeter length implant, they have a drill for 7 millimeter length, and then the drills are increasing in diameter gradually. And if I have to put an 11.5 millimeter implant, I have an 11.5 millimeter drill. These drills have drill stoppers which are embedded in the drill design. You cannot remove them, but you have separate drills, one for 7.5, one for 11.5, like that, right? So this system might seem most easy to use, nothing to remember. Straight away, if I have to put 10 implant, I just have to use these set of drills. But there is a catch. I told each and every drill starts from 3.5 to 4,000 on an average in any system. These drills have a shelf life. Every time you do 15 to 20 osteotomies at upper limit of 30 osteotomies, they tend to become blunt. So you have to buy new drills. Now, a system which has so many drills to begin with, as compared to a single row of drills, would be more expensive or less expensive than this? Naturally, more expensive. So the cost almost doubles if you go in for a system in which more number of drills are there according to the length of the implant which is being placed. So again, it is a personal choice, but we cannot say that one system is definitely superior to the other system. No. Basically, what we have to remember is that ultimately, if you are investing something, it should be worth the investment. So you can choose any system. Now, once we have broadly covered three different systems, what you have to remember is the next part of atraumatic drilling. We understood the dimensions of the osteotomy. Now, the next part is, if I have to drill the final hole, my osteotomy hole of 3.65 millimeter for a 4.2 millimeter implant, I cannot straight away use a 3.65 drill. If I were to try to drill it like this, lot of pressure would be generated, lot of heat would be generated. So, lot of bone necrosis would be occurring. So, the important thing which we are supposed to remember is that always and always, no matter which is the last drill that you are going to use, always and always you have to start with the narrowest drill, that is the 2 millimeter twist drill. So, first and foremost, it is 2 millimeter twist drill, it is not pilot drill. Pilot drill is something which was present in earlier systems. I don't have it with me right now, but I'll just show you a photograph. So, pilot drill was something which was there, in which the apical, the terminal end 2 millimeter was of non-cutting drill and the remaining drill was cutting. This was termed as pilot drill. So many of our textbooks also mention the first drill as pilot drill. No, pilot drill now is not present in any of the systems. What we are doing basically is that the first drill is 2 millimeter twist drill. Now, for this 2 millimeter twist drill, if I have to use, I need to make my osteotomy at a very low speed. I need to make my osteotomy at maximum 800 to 1200 RPM. Otherwise, lot of heat generation will be there. Bone necrosis would be there. So, here we'll take a stop from the kit and we'll have a look at the apparatus required. So, what apparatus can we use for making sure that the rotations are occurring at 800 to 1200 RPM? Can we use our normal aerotor? Why not? Aerotor rotates in lakhs. So it is RPM is quite high. If you were to use your aerotor, your osteotomy will be very fast. But what will happen? Lot of necrosis would be there. You will be placing your implants very fast and they'll be coming out also very fast. So never ever think you can use an aerotor. What about a micromotor? Now, micromotor, this is a normal manual micromotor, but we can have a digital micromotor also. Manual means no digital controls are there. So, if I were to use a digital micromotor, I can set the speed which is required for atraumatic drilling, 800 to 1200 RPM. But there is a catch still. The necessary torque which is required for keeping my drill rotating inside dense bone cannot be generated. What that means is that if I were to use a micromotor for osteotomy preparation, my drill will get stuck at 800 to 1200 RPM because the necessary torque, rotational force required to rotate the drill cannot be generated. So I'll have to increase the pressure. If I increase the pressure, what does that mean? More of heat production, my implant will fail. So that is why you cannot use micromotor also. What you are supposed to do is, this is the Physiodispenser I've been using now for almost 12 years, of instrument and equipment known as Physiodispenser. So what is the characteristic of this Physiodispenser which is not present in aerator or micromotor? The characteristic is a quality known as gear reduction. So if you were to have a look at this handpiece, 20:1 is written. 20:1 is the gear reduction ratio which is available in this Physiodispenser. So what is the meaning of this gear reduction ratio? Gear reduction ratio basically means that for every 20 rotations of this motor, the drill rotates only once. This is the concept of gear reduction, which is used for torque amplification. So once my torque rotating force is amplified, even at 800 rpm, my drill won't be getting stuck inside bone. So in this Physiodispenser, the gear ratio for implants, it has been shown in studies to be used at 20:1. We have various other gear reduction ratios also, for example, 16:1, the one which is used in rotary endodontics, same principle, nothing else. Other gear reduction ratios are also available, but here in implants it is 20:1. The second control which you can see here is speed. You are not able to see from that side, you can come this side. So the second control which all of you can see here is speed. So speed, we can change it like this according to the bone which you are dealing with. So suppose you are drilling in osteotomy for implant in the maxilla, that is where 800 rpm also would be sufficient. But suppose you are doing it in the mandible, dense bone, that is where you will be requiring somewhere around 1200 rpm or 1000 rpm. That is the first thing. The second thing which you can change is torque, the rotational force. So rotation speed is measured in what? RPM. Torque is measured in NCM, Newton centimeter. So suppose the bone is less dense, that is where you can use 30 NCM torque. And suppose the bone is more dense, you are getting a lot of resistance, your drill is not going inside only, you can use 35, upper limit of 40 NCM. So this is the basic control of a Physiodispenser and the basic purpose of a Physiodispenser. Now if you were to have a look at the handpiece, this handpiece is actually a combination of aerator and micromotor, meaning we have a push button for removing the drill, and the drill as such has a notch. That notch, that catch is the same one which we get in micromotor burrs. So while putting the drill inside, you don't have to press the back button, you just have to rotate, it will latch inside. So it is stuck inside, it is engaged. Now for removing, you have to press it and you have to remove it as such. So please understand, this is quite expensive. This handpiece itself is 24,000 minimum. That varies from company to company, but it is quite expensive as compared to the 5 to 6,000 handpiece of aerator or micromotor as such. So this is an expensive piece of equipment in which you have to invest for the progress of your implant dentistry for biological reasons. Biological reason is what? Atraumatic osteotomy preparation. And for that atraumatic osteotomy preparation, we need less RPM without the drill getting stuck inside bone. And that is achieved by the concept of gear reduction, that is torque amplification. So this much is about the Physiodispenser. Let us just wind up the kit now. Okay, you people can say your doubts also, nothing will be coming because of this mic as such. So now we have these set of drills which I mentioned. So I'll just pick up one kit, and with that kit, as I have mentioned, that the basic components are the same in all the kits, right? So these are the set of drills that you have to buy. In this, I would advise all of you to buy the short drills also. So these are the long drills which are 19 millimeter in length, and these are the short drills which are 13 millimeter in length. So where will you be requiring this particular thing, this 13 mm thing? Where would you be requiring this thing? This you will be requiring in a partially edentulous patient in the posterior area. Meaning, suppose I say mouth opening is like this. So, as we go to the posterior area, that is where this length actually decreases. So, now what will happen is that suppose I have to place an implant in the 7 area, and I have an antagonist also present, upper 7 is present. So, if I were to use this particular drill, and if I were to try to use it in the patient's mouth, what will happen is that the moment I will try to keep it parallel in this area, the antagonist would be hitting. So, what I will have to do is I will have to make it like this. This is an issue. So, in such cases, partially edentulous cases in which antagonist is present, we are supposed to use the short drill. Okay. So, short drill basically means what? That if I were to use this drill, I will be able to keep it straight because the antagonist would be far away. So, this is the concept of drills, short drill and long drill. Okay, first thing. Now, the thing is how to start with your osteotomy. If I were to use this drill straight away, the 2 mm twist drill, this drill will slide. It won't be getting engaged in dense bone that easily, right? So, what I'll have to do is textbooks say use round burr. Now, the problem with round burr is it skids like anything. It actually slips on the bone surface. So, my advice, personal advice would be never use your round burr for starting your osteotomy. Always use something known as lance drill. So, what is a lance? Lance is another name for spear. So, this is a beautiful drill for starting your osteotomy. So, starting off your osteotomy, this will demonstrate in the next video, is by lance drill, and then you start subsequently with your other sequential drills. Okay. So, lance drill, this thing round burr. So, once you start, again I mentioned the same thing, the rule of atraumatic osteotomy preparation, respect bone and the bone will respect your implant, is simple. Two things. First, use a physiodispenser, RPM is the key. The second is, if the last drill is of a broader diameter 3.65, don't straight away try to insert 3.65. Narrower diameter first 2, then 2.8, 3.2, 3.65. Is it fine? Now the next point is the osteotomy is made and I am ready to place my implant. You can always use a depth gauge. So, as I said that before opening up your implant packet, you have to verify the depth of the osteotomy. So, depth of the osteotomy can be verified with this. This is markings from 8, 10, 11.5, 13 and 16. Again, it varies from system to system, but the basic purpose of the instrument remains the same. So, this has two sides. One side is basically 1.9 millimeter diameter, the other side is of 2.7 millimeter diameter. So, 1.9 you will be able to put after your 2 millimeter drill, and the other side, that is of 2.7 millimeter, you will be one side you will be able to put even before this thing, the other side you will be able to put only and only after you have prepared it with 2.8 mm. So, once you have done the 2.8 mm drill, you can use your depth gauge, and can you see this has a disc like this, a sort of a disc hanging here. Are you able to appreciate? This disc is basically, this extension is basically for checking the walls of the osteotomy, that whether the walls are smooth or not. So, once you have checked that my osteotomy is smooth, it is deep enough, now you are ready to open up your implant packet. So, this packet I won't be opening up, but I have a dummy implant here. So, suppose any implant for that matter is basically consisting of, we have three main components: the implant proper, the mount, and we have the cover screw. So, these are the three main components which are there in any implant packet. Mount, many a times few implant companies don't supply, so that is a personal choice. So, now what we have to do is we have to take it out of the packet as such. You can use a hand also, and then you have to engage it inside that osteotomy site. So, you have engaged the implant carrying the mount here. So, once you have engaged the mount and the implant inside the osteotomy, now you have to tighten up the implant in that osteotomy. Now, for tightening this thing, you require force. Why do we require force? Because basically what has happened is the osteotomy was narrower and my implant is wider. For generating that force, you have to use the most expensive instrument in the implant kit, and that is torque ratchet. So first and foremost, it is a ratchet, not a wrench. So ratchet basically means it rotates in only one direction, the other direction it is free. Wrench basically means that ultimately, just like we loosen up our tire, if you have a flat tire in a car, we have a wrench, you loosen it up and then you have to remove the wrench, then put it again for loosening or tightening as such. That removal is not possible again and again in the patient's mouth. So we have a torque ratchet, the most expensive instrument, roughly around 14 to 18,000 rupees, depending on the kit. Now this torque ratchet again is of two types, depending on the system that you are using. Toggle type, also known as friction type, and we have the beam type, also known as spring type. So these are the two types of torque ratchets which you can use. The basic purpose of a torque ratchet is, can you see, NCM is written, Newton centimeter, and torque is written. So the values, I'll just read it out for you: 10, 20, 30, 40, and infinity torque. So what that means is that I should be able to place my implant in the osteotomy with sufficient amount of torque to achieve something known as primary stability. My implant should not be too loose in the osteotomy. At the same time, it should not be too tight either. It should not be that I have to make an effort to actually engage it inside that osteotomy. Because if that torque is quite a bit, the implant will go inside with that much amount of force that will crush the surrounding bone, causing something known as compression necrosis in the long term. So again, what did I say? Respect bone and the bone will respect your implant. So I'll just demonstrate the various uses of this torque ratchet. The two types I'll just demonstrate in short. Okay. So what happens is, initially you will be tightening it up like this, and once you have tightened it up, as and when the implant will be going inside, this torque ratchet will start hitting the lips and the adjacent teeth. So at that stage, what you will have to do is, you will have to remove this mount which had come inside that packet, implant packet, and you will have to use the fourth component in your kit, and that is known as extended mount. So the purpose of this extended mount is that now once I engage it in my torque ratchet and I put it in the implant, now what will happen is, can you see, this height has increased. So now the lips and the teeth would be far away, right? So now I can go ahead and do the tightening. So this osteotomy isn't exactly according to this particular implant system, but still we'll just demonstrate it partially. So can you see, now my torque is breaking. So what does that mean? That if I had set it at let's say 30 NCM, I am setting it at 30 NCM. You rotate it and this bar goes up. So you have to rotate it and set it at minimum 30 NCM. And if it starts breaking, that means I am exceeding the torque. So now I can extend it all the way up to 40 NCM. So what am I doing? I am adjusting the torque at which I am placing my implant into the osteotomy site by increasing the torque on my torque ratchet. So here now it is still breaking because this osteotomy wasn't exactly prepared according to this particular implant, but we can just give it a try. So this breaking should not be there. If it is breaking, that basically means you are inserting the implant at a higher force. You are causing some sort of compression necrosis in the long term in the surrounding bone. So we'll just finish it off as such, but so this thing we'll cover up in the next video also, in which placement is there. So now suppose I have been able to place it inside. So this is an example of placement of the implant with toggle type of torque ratchet. We have another implant which has been placed, and this is basically of the other system, iFix. So iFix has a Morse taper or a conical connection rather instead of internal hex. But iFix implant system, I cannot use this particular extended mount. I need the extended mount which is present in the iFix kit, and I need to use the beam type of torque ratchet. The purpose of this ratchet is the same, measuring the torque at which you are inserting your implant in the osteotomy site. Now, in this type of system, I cannot set the torque. Can you see? We have the same torque written. We have 15, 25, 30, 35 NCM, but I cannot set it as such. Here, I could have set the torque, and after, once I would have exceeded that torque, it would have broken like this, right? Here I cannot set the torque. Here the thing is that I'll be using that extended mount and I'll be putting it in the implant system, and once it has engaged into the implant system, I'll be tightening it like this. Once I'll be tightening it, in between, if I want, I can measure the torque. So for measuring the torque, I'll be leaving this portion of that instrument and moving this pin. So wherever this pin is ending, that means that is the torque which has been achieved. That is of beam type. So this is the system which was there in Arden, Noble, etc. Here, how do you measure? You measure in between, but do you use the pin for actually tightening the implant? You don't use the pin. You use it only for measuring torque. The tightening part is done with this. And suppose I want that my implant is going a bit too tightly. I want to expand the bone. So I want to take out the implant slightly. What I can do is this arrow, if it is pointing towards me in this torque ratchet, the implant would be going inside. If this arrow, we turn it and we point it in the opposite direction, now I can basically unscrew the implant. So I am unscrewing the implant from an expansion point of view, and then if I move it back again like this, now I can put it inside. Now it is going inside, and in between I can measure the torque. So this is one advantage of the beam type, that while implant placement, if you want to expand the bone, take it out and put it back again, you just have to twist this pin. On the other hand, suppose the same thing would have been required in the case of toggle type of ratchet. In the case of toggle type of ratchet, I wouldn't have been able to take it out like this. So if I have to insert my implant, in has to be facing me. Now if I have to take it out partially for bone expansion, this out has to be there. I need to take it out like this, and then again I have to put it like this. So the important thing is, please understand, implant is surgery first, restoration much later. So the problem is, never ever leave any instrument unattended in the patient's mouth, otherwise the patient might end up ingesting that instrument. So this is the issue. If I have to remove it and put it back again, please remove it entirely, then place it here, then place it here. Is it fine? So this was about the torque ratchet and the extended mount. And finally, the implant is placed. I cannot leave it like this. My implant is like a cylinder. That cylinder is solid cylinder throughout, but the upper 2 millimeter is hollow, known as crest module, right? So that crest module is the portion in which my abutment, that is part of the crown, would actually be fitting. So I cannot leave this hollow portion like this. So this is where the last component, the commonly used component of the kit, comes into the picture, hex driver. So with hex driver, we are supposed to remove the cover screw which is provided in the implant packet, and we will be putting the cover screw on top of the implant. So it is rotating. So now the cover screw has been placed. So this is hex driver, right? Used for placement of the cover screw in the first stage surgery. Okay. So did we understand the first 5 important components of the most commonly used component? Sequential drills, depth gauge, torque ratchet, extended mount, and hex driver. Many a times confusion is there between these two instruments. Okay. Now, other than these, we have few additional components also. For example, these are paralleling pins. Paralleling pins basically means that if you are placing multiple implants, if you were to place, if you want that all those implants should be parallel to each other, then after preparing the first osteotomy, initial stage itself, you can put this paralleling pin so that the next osteotomy is done parallel to it. Then leave those 2 pins inside. The third osteotomy also can be made parallel to the first 2 osteotomies. So paralleling pins which are used in the case of multiple implant placement. Okay. The final component which I will be covering is known as drill extender. So, drill extender basically means that just like we had short drills, do you remember? If accessibility is less in the posterior area, in the anterior area, especially with regard to mandibular anterior area, suppose canines are present and we have bone resorption present. In that case, what happens is my normal, even long drill, many a times we are not able to reach that area. So, this drill, it won't be able to reach that area because my teeth on the adjacent sides would be hampering its reaching that depth of the bone. Right now it can reach, but as and when I am going deeper in the osteotomy, this drill will be hitting the teeth on the adjacent side. So, this is where a drill extender comes into the picture. You can attach a drill extender onto this drill, and now once you attach it into your handpiece, it becomes quite long. So, now you will be able to use it easily. So, this is a drill extender, again a useful instrument which can be used. And what else? Let me see. We have motor driven also implant placement can be done. Motor driven basically means that instead of placing an implant manually, we have a choice. We can just put this motor driven part into the handpiece, and now we can directly pick up the implant like this from the implant packet, and instead of tightening it manually with a torque ratchet, you can just set the torque in your Physiodispenser and you can tighten it here. Is it clear? Okay. So, I feel that the basic components have been covered. Any doubts we can discuss later on also. So, we hope that our demonstration of the implant kits which we did for our first year postgraduate students, all of you were also able to understand, and our audience also would be able to understand. So, this was a brief overview in which we covered up all the portions of all the kits, the Physiodispenser, etc. In our next video, we will be demonstrating the actual placement of the implant, that is the drilling in an artificial mandible. So, thanks a lot for your patient watching. Please do subscribe to our departmental channel of PERIO Subharti, which comes under our name, Dr. Mayur Kaushik. Thanks a lot. Jai Hind.